Hello everyone, today we will be learn about clustering in social graph, uncovering communities and pattern. This presentation explores how graph clustering techniques are used to identify meaningful communities, detect hidden patterns and extract valuable insight from complex social network data. What is social graph? A social graph is a fundamental structure in network science that models how entities connect. It represents entities, users, post, organization, edge nodes, and their relationship, friendship follows, like, replies, interaction, edges. The sheer scale of this graph is massive. For example, platforms like Facebook and LinkedIn connect billions of people, billions of nodes, enabling dynamic information flows and formation of communities. Understanding the topology of this graph is the first step towards extracting social intelligence. Analyzing the density and structure of this connection allow us to move beyond individual relationships to understand collective behavior. Why cluster social graphs? Clustering is the process of partitioning the graph into groups where the connection within the group are dense and connection between groups are sparse. This reveals the intrinsic community's structure. Identify core communities. Discover natural grouping like friend circles, interest-based forums, or professional network that share common traits or frequent interaction. Reveal influence structure. Pinpoint influential communities and keep bridge nodes that connect disparate groups, crucial for diffusion models and targeted outreach. Enhance data analysis. Reduce the complexity of the entire graph by focusing analysis on a specific, a smaller, coherent cluster, improving efficiency and insight extraction. Clustering transform a massive, undifferentiated network into a structured landscape of meaningful social unit. Key clustering algorithm for social graph. Choose the correct method is crucial as different algorithms are optimized for varying graph characteristics such as size, density, and desired cluster output. K means clustering. Partitions nodes into a predefined number K of cluster based on distance or similarities. It is a fast and efficient for dense graph but require prior knowledge of optimal value K. Binary tree partitioning (BSP), a top-down recursive method that efficiently splits the data space using hyperplanes, highly effective for scaling to extremely large social networks due to its hierarchical nature. Community detection methods. Algorithms like Llewellyn or Waltrip especially optimized for modularities, a measure of the strength of the community division. They automatically finds natural clusters without needing a preset number. Case studies. Binary space partitioning (BSP). VSP stand out for its high performance when dealing with the colossal scale of modern social media graphs, where other methods become computationally prohibited. How BSP works. It begins with the entire network and recursively applies a split, effectively dividing the graphs into two parts at each step. This creates a hierarchical structure, making it possible to analyze communities at different level of the granularity. The efficiency of the recursive splitting allow for rapid processing of dense, high-dimensional social data. BSP's speeds and adaptability make it a favorite for platforms like Twitter or LinkedIn, where real-time analysis of network dynamics is essential. Real-world application of social graph clustering. Clustering is not just a theoretical concept, it drives critical business and security function across multiple industries. Targeted marketing. Brands identify a small, highly influenced, engaged influencer group, micro communities on platforms like Instagram to launch highly effective niche niche advertising campaigns. Security and fraud detection. Anomalous clustering patterns such as a dense group of the users with identical non-human interaction pattern can quickly expose fraudulent account or botnets. Recommendation system. Clustering users with similar behaving or purchasing histories. Example Netflix, Amazon allows platforms to provide highly personalized and accurate content suggestion. Security and fraud detection. Anomalous clustering patterns such as a dense group of the users with identical non-human interaction pattern can quickly expose fraudulent account or botnets. Public health tracking. Researchers clusters contact network to model disease transmission and understand how behaviors within communities affect pathogens spread and mitigation efforts. Challenges in social graph clustering. While powerful, clustering large real-world social graph presents several significant technical and conceptual hurdles. Algorithm selection. The optimal algorithm depends heavily on the network's specific characteristics, example directed versus unidirected edges, network size. A, a poor choice can yield meaningless result. Dynamic graphs. Social relationship constantly changes. Maintaining cluster accuracy requires computationally expensive, frequent reclustering to keep up the graph's evolution. Overlapping clusters. Real people often belong to multiple communities, work, family, hobby groups. Standard clustering models struggle to assign a new node to more one group accurately. Efficiency versus accuracy. Massive graph demands scalable algorithm, often forcing a trade-off where computational speed is prioritized over nuisance of the clustering result. Visualizing cluster from data to insights. Effective visualization is crucial for interpreting clustering results, transforming complex mathematical partitions into actionable social insight. Graph visualization tool like Gephi or Cytoscape render nodes and edges, allowing analysts to interactively explore the network. Clusters are often visually distinguished by color or spatial proximity, immediately highlighting the discovered communities. Identify bridge nodes. Nodes connecting two or more clusters is vital for understanding information flow and cross community influence. A visual comparison of the raw messy graph versus the Clustered, organized graph provide a powerful narrative of discovered social structure. The future of clustering in social graph. Future development in clustering will focus on adaptability, security, and integration with advanced machine learning techniques to handle increasingly complex stream. AI enhanced adaptivity, integrating clustering with deep learning and reinforcement learning allow for adaptive real-time communities detection on continuously streaming social data. Misinformation detection. Enhanced clustering technique will better identify coordinated inauthentic behavior and influence campaigns by detecting tightly organized rapid growth cluster. Privacy preserving methods. Developing methods to cluster social network without compromising user data crucial for decentralized and privacy focused platform. Conclusion. Unlocking social insight through clustering. Clustering is an indispensable technique that transforms the daunting complexity of the social graph into understandable, actionable knowledge. A strategic advantage. It provides businesses, researchers, and policymakers within the necessary tools to understand and influence the underlying dynamics of the social interaction. Navigating complexity. As social networks continue to grow in diversity, clustering remains the most vital tool to navigate and harness their immense potential. Embrace graph clustering to reveal the hidden communities shaping our connection world.